Okay, so now we're really getting into, well, I know I keep saying this, one of my favorite things within Trig. This is like almost there. So we're going to be doing what's called simplifying trig expressions. And think of this as like you doing a puzzle, which you all love because puzzles are awesome. So, you know, you're trying to put together the puzzle. The only problem is somebody threw out the box. So you don't know what the picture's going to look like. You've just got all the pieces. Let's say someone put all the pieces in a Ziploc bag and you're just trying to put it together. That's what this is like. So what we're going to try to do, we're going to use identities. So we're going to do substitution of identities, and we're going to do some basic algebra. So here are our strategies. Like I said, we're going to substitute identities. We might distribute, which would be multiplying things. We might combine fractions, so we would need to get a common denominator. So think about that means multiplying by 1. So when we combine fractions, we could be adding or subtracting them. We might split up fractions. So we've seen that technique in some of our previous examples where if we have a common denominator, we can split the fraction up into two separate fractions. Or we might substitute for Pythagorean identity. So a big hint, anytime you see squared trig functions, you might need to use a Pythagorean identity. If all else fails, change everything to sines and cosines. This will almost always work, but it's not always the best strategy. Okay, so let's do a couple of examples together. So here I have tangent of x times cosecant of x. How can I simplify that? That seems pretty simple already, right? It's one term, it's just two different trig functions multiplied together. How can that get much simpler? But wait, it can. So my first thought process is there a relationship from the identities I know, and right now we're just focusing on the reciprocal, the quotient, the Pythagorean identities. So do I see one of these that has tangent and cosecant in it together? I don't. So what that tells me is, well, a big hint would be to use my quotient identity, and I can change tangent into sine of x over cosine of x, and my reciprocal identity, and I can change cosecant into 1 over sine of x. That's sine of x. Now you might be asking yourself, well, how do I know how to do that? So again, my thought process was, right now I'm just using the reciprocal, the quotient, the Pythagorean identities, and I don't see an obvious relationship between tangent of x and cosecant of x, so I'm just going to change them into sines and cosines. Now I'm going to see what happens, but wait, I'm multiplying, and I have a sine in the numerator and a sine in the denominator, sine of x, sorry. Those will cancel. So now what am I left with? Oh, look at that. I'm left with 1 over cosine of x. But wait, what's 1 over cosine of x? That is going to be secant of x. Oh my god, that did simplify. Look at that. Now, again, I want to point out, I am not making a bunch of equal signs going horizontally. I am just working vertically. This is how you should do this type of work to show your work, basically. Okay, next one. Let's talk about this. So here I have 1 minus cosine squared x, and I have cosecant of x. Again, if I look at my identity sheet, I see, okay, well, I don't see an obvious thing that relates, but what I do notice is that 1 minus cosine squared of x, I know that that is sine squared of x from my Pythagorean identity. And remember, we talked about this when we went over the Pythagorean identity. So I can substitute sine squared of x here, and I have cosecant of x. But wait, sine and cosecant, those relate. Those are reciprocals of each other. So I can change one of these into the reciprocal of the other. Don't change both of them. So I'm going to actually leave the sine squared of x, and I'm going to change the cosecant into 1 over sine of x. Now I can reduce this, and I'm left with just sine of x. See how much fun that was? See? It's like a puzzle. Now, I would point out again, we're not always going to simplify it down to something really nice like this. There are going to be times when you're going to look at the answer and you're going to be like, oh, that doesn't seem that much simpler, so to say, again, air quotes, than what I started with. But that's because, you know, we didn't know what the picture on the box was to begin with. Okay, so let's do another one together, and then I'll have you try some as well. So here, I have cosecant of theta. This is theta, not theta. Tangent of theta plus secant of theta. I've got three, so this is my thought process. I've got three different trig functions separated by, separated into two terms, separated by addition. Two of the trig functions are multiplied as a single term, but they're all different. So this is a big hint to me. Well, every trig function relates to either sine or cosine somehow, so I'm just going to change everything to sine and cosine right away, because I don't see anything obvious between these three. So let's just go ahead and make this 1 over sine of theta times sine of theta over cosine of theta plus 1 over cosine of theta. And conveniently, those are going to reduce, and so what do we get? 1 over cosine of theta plus 1 over cosine of theta. Conveniently, those have a common denominator already, so we can go ahead and add them, and this becomes 2 over cosine of theta. But what is a cosine in the denominator? That's just a secant in the numerator. So this becomes 2 secant of theta. We could have just, so I want to point out there's not one correct way always to do these. So at this stage here, I could have changed everything into secant, right? And then I could have just added them, and I would have also gotten 2 secant of theta. Okay, next one. I want you to try this on your own. So pause the video, unpause when you are ready to discuss or when you think it's simplified. Okay, so here, this doesn't really get much simpler than this. It simplifies down to 1. How did I do that, though? So again, my thought process is I have sine of theta times secant of theta times cotangent of theta. So this is actually considered pretty simple to begin with because this is all one term. It's just 3 separate trig functions multiplied together. Since it's 3 different trig functions, again, I know this has been the theme so far, but my thought process is, well, let's just get everything to sines and cosines. One of them is already in terms of sine. So I changed the secant of theta into 1 over cosine of theta, and I changed the cotangent of theta into cosine of theta over sine of theta. Now I realized the cosine of theta is canceled because I had 1 in the numerator and 1 in the denominator, and here the sine of theta cancels with this sine of theta because 1's in the numerator and 1's in the denominator. All I'm left with is 1. Next one. Again, I want you to try this on your own. So we've got secant of beta minus sine of beta times tangent of beta. Pause the video, unpause when you're ready to check. Alright, so here our answer simplifies down to cosine of beta. Who would have thought that when we started with secant of beta minus sine of beta times tangent of beta, that would just become cosine of beta, right? There's not even a cosine in there to begin with. Who knew? How did we come up with that? Alright, well, so again, my thought process, I have 3 different trig functions. 2 terms separated by subtraction. 2 of the trig functions are multiplied together to get 1 term, and then a separate trig function over here on the other side of the subtraction. So since I have 3 different trig functions, my thought is get everything in terms of 2 if I can. There are, again, other ways I could have approached this, so I just want to point that out. So I changed secant into 1 over cosine of beta. I left the sine of beta, and I changed tangent of beta into sine of beta over cosine of beta. Now I combine terms here. So sine of beta times sine of beta over cosine beta is sine squared beta over cosine beta. This one stayed the same. Now I noticed I have subtraction of 2 fractions. They already have a common denominator, so I can combine them. So this becomes 1 minus sine squared beta over cosine of beta. But 1 minus sine squared beta is a Pythagorean identity. That is rearranging my Pythagorean identity, sine squared theta plus cosine squared theta equals 1, right? If I subtract the sine squared. So I know that 1 minus sine squared beta is cosine squared beta. Cosine squared beta over cosine beta, that just reduces to cosine beta. Take a minute and take it all in. That's good stuff right there. Alright, challenge. See if you can do this one. Now pay attention to the parentheses here. So this parenthesis and this parenthesis are saying this whole thing right here is one quantity times the cosecant of x. Right? So try this one on your own. You can do it. I believe in you. Pause the video. Unpause when you're ready to check. Alright, did you get negative sine squared x? I bet you did. You know why? Because again, I believe in you. So, how did we get that though? Well, again, I have a lot going on. I've got 1, 2, 4 different trig functions. My thought process, let's change everything to sine and cosine, especially since I have cosines and sines to begin with. So I changed this cosecant into 1 over sine. I left the cosine cubed of x. I changed tangent of x into sine of x over cosine of x, and I left this sine of x. Now what I noticed right away was the cosine cubed of x and this cosine of x are going to reduce. So this became cosine squared of x, and here this cosine of x is gone. So my second step, I've got 1 over sine of x times the quantity cosine squared x sine x, so these are multiplied, minus sine of x. Now what I noticed was I have a sine of x in these two terms separated by subtraction, so I factored out sine of x. That's what I'm trying to show you here. That's why I underlined the sine of x's in red. That's what this became. So this 1 minus sine of x stayed 1 minus, or I'm sorry, I said 1 minus, 1 over sine of x stayed 1 over sine of x. This sine of x is when I factored out these two sine of x's from each term. Then I was left over with cosine squared of x, and then minus 1 because I factored out sine of x. So now this sine of x reduced with this sine of x, and that becomes a 1, so I can kind of ignore it since it's multiplying by 1. And cosine squared of x minus 1 is what I was left over with in the parentheses. But, again, from my Pythagorean identity, if I subtract the 1 and I subtract sine squared, cosine squared of x minus 1 is going to equal negative sine squared of x. So that's how I got my negative sine squared of x. There you go. So, just recap. Use your identities. Use the identity sheet that I've provided you. Again, when you get to an actual trig class, you might need to memorize these. But for now, use the sheet. Try to get comfortable with this. Use your strategies of algebra. And it just takes practice getting used to, just like a lot of things. I know. But most importantly, as always, have fun.